Okay, transforming parabolas. Today we're going to talk about the second half of the transforming parabolas lesson, which is all about how to sort of solve for missing pieces in order to write the equation of a parabola. So, writing the equation of a parabola when you are given the graph. You're going to take the graph, you're going to use what you know from the graph. Here's your vertex. We have to know h, k, and a in order to write the equation. These are the things that we need to have. And right now in this particular problem, I have h and k. I can get that right from the picture. So here is my 3, 4. And I'm going to plug that into my equation. Remember that f of x is the same thing as y. So my x, my h is 3, and my 4 is k. So far that's what I have plugged into my equation. Okay? Take h and k from your graph, substitute it into the equation. Now, identify a point on the graph and substitute it for x, y. So I have chosen this point. It seems to be right on an actual ordered pair, 5, negative 4. And I'm going to add that to my equation as well as the 3, 4. So y equals a times x minus 3 squared plus 4. And now I'm going to put those in there as well. So in place of y, I'm going to write negative 4. And in place of x, I'm going to write 5. So now my equation says, and this is just a rewriting of what we were doing, always in standard form. So standard form, first plug in your hk, then find your xy, plug them in, and then you've got everything plugged in, and the only thing you're left to do is solve for a. We had hk, we're using it, and a point on the graph to solve for a. 5 minus 3 is 2, squared is 4, so negative 4 equals 4a plus 4. 4a equals negative 8, and negative 8 divided by 4 means that a is negative 2. Awesome. So we have a. Step 4, now you have h, which we know to be 3, k is 4, a is negative 2. Substitute it into the equation to write the equation of the parabola given the graph. So I have the function is negative 2 for a, and then x minus 3 squared plus 4, and you've just written the equation of a parabola using the point on the line and its center, or its vertex. We used it to solve for a. Okay, so now we're going to try one. Example with the graph given. So I've given you the graph right over here. We're going to do the exact same thing we just did, okay? So maybe a little more streamlined than all of those steps up there. Start with your vertex form of your line. Find the middle. Here it is, hk, 2, negative 5. So h is 2, and k is negative 5. And then this is the point on the line. And remember, the point on the line is same thing as xy. And remember, f of x is the same thing as y. So in place of y, I'm going to put negative 3. I don't know a. In here, I'm going to put the x coordinate, which is 0. And then I'm going to solve for a. Whoops. Solving for a. Negative 2 squared is positive 4, so I get negative 3 equals 4a minus 5. Add 5 to both sides. 4a equals 2, and divide by 4. a equals 1/2. I have a, I have h, and I have k, so I can write the equation of the line. F of x equals 1/2 times x minus 2 squared, whoops, minus 5. There is the equation. Okay, now let's talk about how to do this when you do not have a graph given. Same exact thing. I just told you your vertex is hk, and I just told you that this is a point on the line. So essentially, we're going to do the same thing we just did. And if you like to write, oh, I'm sorry, I didn't mean to put a 3 here. This is supposed to be our h and our k. If you like to use y here instead of f of x because it confuses you, then just use y equals. It's the same thing. Plug in your h, your k, your x, and your y. So y is 4, x is 2, h is -1, so I'm going to be subtracting a -1. I'll have to remember to make that a positive. And then k is -2. So 4 equals a times 2 plus 1, negative, plus 1. So 3 squared is 9. 4 equals 9a minus 2. 9a equals 6. Divide by 6. And a equals, I'm sorry, we're not dividing by 6. What am I doing? We're dividing by 9. I'm trying to read another page at the same time as I'm talking. Divide by 9. 6 over 9 simplifies to 2/3. So I have a, I have h, I have k. F of x equals 2/3 times x plus 1 squared minus 2. There's your equation. So really we just use the graph to get the points. Okay. On the next page, identify the vertex and the y-intercept. So here's my point, here's my equation, my example, and if I do this, underneath it, I can identify the hk right from the equation. Remember, h always has the opposite sign. So instead of positive 20, h is actually 20, because this was minus -20. That's how it became positive 20. So this is really h, -20. So h is -20. And k, since there's nothing written out here, is 0. So I have my hk, and then I'm going to use hk, and I'm also going to use the y-intercept. I know that the y-intercept is always the equation 0c, or 0y, which means x is always 0. Since the x value of the y-intercept is always 0, we plug in 0 for x and solve for y. So we're really looking for this coordinate over here. When x is 0, y is what? So I'm going to do that right now. I'm going to take that original equation and I'm going to plug 0 in for x. Okay? And let's find out what we get. We get -1.5 times 20 squared. 0 plus 20 is 20. And 20 squared is 400. And then I'm going to multiply that out and get -600. So the y-intercept is -600. And so that we've used this, and we've found both the vertex, hk, and the y-intercept. So we've done both things we needed to do there. Here's an example. Let's try it. Okay? So we're going to do the same things we did here. We're going to identify h and k. So h is 3.2 and k is 0. So we have hk, and the other thing we need is the y-intercept. So again, we know that the y-intercept occurs when x is 0. So I'm going to take this equation and I'm going to put 0 in for x because that's how it's